Kaiser student, and today I'm going to be going over the reciprocity law, the inverse square law, the direct square law, and the 50% rule. The importance of these radiographic formulas is to help the radiologic technologists choose the correct exposure factors while avoiding unnecessary repeats. The reciprocity law is a law used to maintain the same density even though the factors change. What you are choosing here is a different MA and time different than from the original image. Both images should give you the same radiographic density. The following images will help in demonstrating the reciprocity law. This is a cervical spine x-ray taken on a patient. On this image, 100 MA and 1/10 seconds was used. As a result, I got 10 MAS. The next image of the cervical spine, the MA was increased to 200 and the second was decreased to 1/20. As a result, I got the same MAS, which was 10. So what I'm trying to explain is that using the reciprocity law, MA and time is inversely proportional. The inverse square law is a relationship between the radiographic density and the SID, and how it is inversely proportional to the square of the distance. For instance, if you have a distance of 72 inches compared to a distance of 44 inches, the radiographic density will decrease with the distance of 72. So when the distance increases to 72, the MAS needs to be increased. The formula comes good in hand when you change the distance so you can get the correct MAS needed to obtain a good diagnostic image. What we have right here is the inverse square law, which the formula is I1 over I2 equals D2 over D1 squared. This question says a radiographic exposure of a lateral cervical spine was taken at 72 inches SID using 10 MAS and had an exposure of 50 MR. What would be the exposure of a distance of 80? First of all, we don't need the MAS. Then I1, which is the intensity, is 50 MR. I2, we don't know yet. That's what we're trying to figure out. So we put an X. Distance 2 is 80, and distance 1 is 72. So when we plug it in into this formula, it would be 50 MR over X, because we don't know the value of this yet. D2 is 80, D1 is 72, and we square it. Okay. So first I do the what's in parentheses. So 80 times 80, 6,400 over 72 times 72, 5184. Then we cross multiply. 50 times 5184 is equal to 259, 200 is equal to 6,400 X. Then to leave X by itself, we divide 6,400 on both sides. And it gives us 40.5 MR. The direct square law is used to maintain the MAS. For example, when the distance increases, the radiographic density increases, making the relationship between the MAS and distance directly proportional. Okay, so this is a direct square law question. This says an acceptable radiograph of 40 MAS, 80 kVp, 60 inches SID was taken. The second radiograph was taken at 40 inches SID. What MAS should be used to maintain the original density? When it says maintain, we have to use the direct square law, which is MAS1 over MAS2 equals distance 1 over distance 2 squared. KVP here doesn't matter. So the MAS they gave us is 40 over X because we don't know the second MAS. The first distance is 60 inches. The second one is 40. So now we square this. 60 times 60 is 3,600 over 40 times 40, 1,600. 40 over X. Now we cross multiply. 3,600X equals 40 times 1,600, 64,000. And now we have to divide by 3,600. And our new MAS2 is 17.77. Now I'll be going over the 15% rule. The 15% rule is a great technique to use when you take an image and you're not satisfied with the outcome. The 15% rule influences the contrast and the overall density. The 15% rule states that if the KVP increases by 15%, the density is doubled. And if the KVP decreases by 15%, the density is half. And when we are trying to maintain the density and the contrast, then it's the opposite. And to maintain, when KVP increases, then you divide the MAS by 2. And when the KVP decreases, you multiply MAS by 2. In conclusion, these radiographic formulas are very beneficial for the technologists at any circumstance. These formulas will help when contrast or density needs to be adjusted, or when distance gets increased or decreased and you need to find the new exposure factors, or simply when you need to change the contrast or density by just 15%.